Welcome everybody to Math 1314, more on math. Today we're going to talk about Chapter 4, Section 6, Polynomial and Rational Inequalities. The objectives of this is first we're going to talk about polynomial inequalities, and then we'll look at rational. Remember, rationals are fractions. We're going to look at equations that look like this. Alright, so in the first section, I'm going to show you how to use a series of algebraic and graphical methods to solve these polynomial inequalities. But then I'm going to show you shortcuts to do it all. And polynomial inequalities are simply polynomial equations that instead of having an equal sign, say equals 0, they have less than, equal to, greater than, equal to. So this is the main difference. We're used to doing this with equal 0, and now we're going to do it with inequalities. The way you solve these, remember earlier in Chapter 2 or Chapter 1, when we first talked about inequalities, whenever I give you an equation, the first thing you have to do is change inequality to an equal sign. Change the inequality symbol to an equal sign. When you do that, that's called a relation. Related equation, or a relational equation. Also relational. What that means is one side is related to the other side based on a specific value x, or a couple of x, a series of x's. So first thing you do is convert the inequalities to an equal sign. Solve the polynomial. The way you do that, set equal to 0. And find all the factors. Once you find all the factors, replace the inequality in place of the equal sign. Alright, so for example, let's say we had our first polynomial is f of x equals x squared minus 4x minus 5. You said solve it. So first thing we have to do is set this equal to 0, and we factor it. So remember, it's the middle letter that goes in here and here. I have two of them. The second symbol is a negative, so that means the signs are different. One's a plus, one's a minus. The bigger number gets that first sign. So, what times what equals 5, this last number? When you subtract them, in this case it's whatever that second sign is, it equals 4, the middle term. So what times what equals the last term? When you subtract them, you get the middle term. 5 times 1, 5 minus 1. So, since the first sign is a negative, the 5 goes in the negative. And then we go ahead and solve these. Set these equal to 0 and solve them. We get these 2 points, the intercepts. So we say our first intercept is at -1, 0, and the second one's at 5, 0. All right, so that's the important part. We have to understand when we find the intervals, when we find the intercepts, that creates a distinct series of numbers. These numbers are called critical values. In polynomials, the critical values are the x values, we call them the zeros, that make the polynomial equal to 0. So remember, they're these zeros. They're also the x-intercepts. All right. So our zeros, our x-intercepts, are -1 and 5 in our example. If we look at our graph, so the first x-intercept is at -1. The second one is at 5. I'll write the equation down again. F of x equals x squared minus 4x minus 5. The factors were x minus 5, x plus 1. So, looking at this equation, we see it's degree 2. Since it's a degree 2, it's a quadratic equation, the graph either looks like this or like this. Since the leading coefficient is positive, if a is positive, it looks like that. If a is negative, it goes down. So since our a equals 1, and that's greater than 0, our graph will go up. In other words, both ends point the same direction. So since these are only 2 intercepts, our graph from those 2 points will go up. The multiplicities, they're both 1, so they cross the x-axis there. We know the y-intercept is at -5. So when we set a polynomial equal to 0 and we graph it, we have intervals. These are our critical values. We'll call them CVs, because to the left of -1, the graph is above 0. The graph is positive. So from -infinity to -1, the graph is positive. It's above the x-axis. Between -1 and 5, the graph is below the x-axis. It's negative. It's below the x-axis. And then from 5 to positive infinity, it's back to being positive. The graph is above the x-axis. Because now what we're doing, once we set it equal to 0, we're either going to have, we have part of the graph above it, below it. That's what we have to look for. Which is where the inequalities come in. All right? So again, because we have to know, we know the degree, we know what it looks like. So, in this example, let's say my polynomial, I wanted it above 0. The polynomial is greater than 0. So what that means, I'm only looking for answers that are positive. So my solution to this equation, since I only want things that are above the x-axis, my answer is from negative infinity to negative 1, unioned with 5 to infinity. Those are my answers. Because any x's inside those parentheses, in those ranges, will give me an answer above 0. That's what our objective is. We are looking for x values that place the graph of the polynomial either above or below the x-axis. So since this one, the polynomial is greater than 0, I only want above 0. What if I asked, what are the x values less than or equal to 0? So I factored the equation, I solved it, I graphed it. Since I'm looking for all the values less than or equal to 0, I start from negative 1. I only want these numbers. I also include negative 1 and 5 because it's equal to. So my answer here is, set bracket negative 1 to positive 5 because we can include those values. All right, let's look at some examples here. X squared plus 3x minus 5 is less than equal to x plus 3. So here we're going to use the same things we did earlier in the semester. Since we have x's on both sides, remember one side has to be 0, we always move the smaller x's to the larger. Since that's an x squared, that's the largest. So we have to move these to the other side. I subtract x, and I also subtract 3. So that disappears, so I have a 0. So here I have x squared. 3 minus 1 is positive 2, because 3 is bigger. Negative and negative, the answer is going to be negative. 5 plus 3 is 8. So I have a polynomial, and I have it with each 0 on one side. So now I factor. I want the x's, there's two of them. The second sign's a minus, so one's a plus, one's a minus. What times what equals 8. When I subtract them, it equals 2. Four times 2 is 8. 4 minus 2 is 2. So since the first sign is a plus, the bigger number goes there with the plus. So I took that, I factored it. I solve these two equations. Remember, it's always going to be the opposite of what's inside the parentheses. So these are my critical values. They're also my zeros and my x-intercepts. So let's graph it. We're graphing this one, not the original one. Has to be everything to one side. So that's the equation we graph. So we know the y, so we're graphing this equation. X squared plus 2x minus 8. We're graphing that one. We know my first x-intercept is a -4. My other one is x equals 2. My y-intercept is the constant 5, 6, 7, 8. So we know the points. Now we also, the degree of the equation is 2, it's the highest power, and the coefficient in front of x squared is 1, which is greater than 0. So the degree 2, the ends point the same direction. Either they both point up or they both point down. They point up if a is positive, they point down if a is negative. Since a is greater than 0, the graph looks like this. So we know at the left side it goes up, and the right side it goes up. So the zeros and their multiplicities. So the zeros are -4 and 2. The multiplicities, since they only happen one time each, are 1. That's important because if the multiplicity is odd, then it crosses the x-axis. If it's even, then it bounces off the x-axis. So since both of our multiplicities are 1, we know our graph crosses the x-axis at that point. And it has that shape. And it has to cross through -8. So it's going to have that shape. So we have the graph. Our equation we're looking for is, where is the graph less than 0? This is greater than 0. This is less than 0. So what part of the graph is less than? Below the x-axis. And remember, we can use the endpoints because of that might equal sign. It starts at -4 and it goes to 2 and it's bracket. So that's your solution. Because from -infinity to -4, the answer is above the x-axis. From -4 to 2, the graph is below the x-axis. And then from 2 to infinity, the graph is above the x-axis. So, let's look at another example. F of x. The function itself equals x cubed minus x. Find f of x is greater than 0. You'll sometimes see it this way. Okay, so this is our function f of x is this. We're looking for f of x is greater than 0. F of x is x cubed minus x. So let's factor it. Only two terms. They both have an x, so we factor out an x. If we take out one x, that means I have 2 left here, and I have a 1 there. Okay, now, remember some time ago I told you, whenever you factor something out, to figure out what goes inside the parentheses, divide your original equation. X cubed divided by x is x squared. X over x is 1. X squared minus 1. 1 equals 1. 1 equals 1 squared. 1 equals 1 to the 10th. So 1 is 1 to the any power. Why is that important? Because in this case, I have the difference of 2 squares. The difference of 2 squares has this formula. If you have two terms that are squared terms, perfect squares, have the minus between them. AB, AB. So whatever's under the squares. One's going to be plus, one's going to be minus. That's called the difference of 2 squares. So whatever's under the squares, go in those positions. One's a positive, one's a negative. Now we have factored. The first x, its power is 1, that power is 1. So those are the multiplicities. Remember, if you add the multiplicities, you get the degree. The degree of the equation is 3. It's a cubic function. A, the number in front of x cubed, is 1. That's greater than 0. Remember, a third order equation looks like this, or like this. In other words, the ends go different directions. Since A is positive, whenever we say it's positive or negative, look at the far right-hand side. If it's going up, it's positive. If it's going down, it's negative. So we want this one. Our graph's going to look like this. Now, we have what are our zeros and their respective multiplicities. So if we set this one equal to 0, x 0 is 0. Its multiplicity is 1. It only happens one time. X plus 1 equals 0. X equals negative 1. So the 0 is negative 1. Its multiplicity is also 1. And the last one, x minus 1 equals 0. X equals 1. Its multiplicity is also 1. We also know, since we have no constant term, the y-intercept is at 0. So we also know that. So we have a 0 there. We have one at negative 1 and at one at positive 1. So we plotted those. We know that each of these, they cross the x-axis. So the far left, from our graph here, the far left, it goes down. The far right, it goes up. And it crosses. So it crosses this one, and it crosses this one. And at 0, it also crosses. So the only way you go from here to here is cut through 0. So there's our graph. All right, let's look at bigger equations now. Solve 3x to the 4th plus 10x less than equal to 11x cubed plus 4. So what's the first thing we have to do? We have to move it. It has to have a 0 on one side. So since that's the 4th power, that's the 3rd, these guys have to move over there. So I subtract 11x cubed from both sides, and I subtract a 4. So that disappears, so we have a 0 on this side. So on the left side, 3x to the 4th minus 11x third plus 10x minus 4. Okay, now what do we do? We could first, this is only 4 terms, we can see if we use grouping. No, it wouldn't have the same functions inside there, so we can't use grouping. So we have to try to figure out the other way. We know what? We know the degree is 4. It's a 4th order equation. So that means the graph looks like this, or like this. Since a equals 3, and it's greater than 0, it points up. So we know our graph looks like that. We know we're going to have 4 intercepts. We also know that our y-intercept equals -4. Alright, so now we got to try to solve this one. Remember from the last section, how do we solve polynomial equations? We have to use synthetic division. Use the P of x over Q of x, where the value 3 is the Q of x, and the last value is the P of x. So we have to find the plus or minus, the factors of all of those. So let's go and figure it out. (3x to the 4th minus 11x cubed plus 10x minus 4. 4 plus or minus 4 over 3. What are the factors of 4? 1 times 4 or 2 times 2. So the factors of 4 are 1, 2, and 4. What are the factors of 3? Either 1 or 3. That means we could have either, let's use that as our first denominator. So we have 1 over 1, 2 over 1, and 4 over 1. Let's do the second one then. So all three on the top. Plus or minus 1 over 3, plus or minus 2 over 3, and plus or minus 4 over 3. 1, 2, 3, 4, 5. 1, 2, 3 on top times 2, it should be 6. 1, 2, 3, 4, 5, 6. Since they're plus or minus, we have 12 possibilities. We could also do the Descartes rule of signs. Let's see how many positives and negatives we're going to have. Sign changes. Positive in front of the 3 to negative. That's one sign change. Negative to positive. That's another sign change. Positive to negative. That's another sign change. So I see that's positive to negative, that's a change. From a negative to a positive, that's a change. From a positive. So for the positive solutions, we have 3 or 1. Remember, you have to subtract by 2. So those are possibilities. That's for positives. Let's look for negatives. So the way we do that, we put a negative x inside the function. So we have 3 negative x to the 4th, 11 negative x to the cube, 10 negative x minus 4. So if it's an even exponent, that negative disappears. So it just becomes 3x to the 4th. If it's an odd exponent, that negative goes in front. So a negative times negative is a positive. This is power 1. So this negative times positive is negative. And minus 4. So it's positive to positive, that's not a sign change. Positive to negative, that's a sign change. Negative to negative, no. So we have, for the negatives, we have one negative answer. So let's go ahead and look at them. Remember, our equation was this. And what we have to do is we have to try plus or minus 1. 2 over 1 is 2. 4 over 1 is 4. 1/3. 2/3. And 4/3. We're supposed to come up with 4 answers. So let's begin. Let's try with positive 1. Remember, we only put the coefficients. This is x to the 4th, x cubed, x squared, x, and constant. So the 3 goes in there. Negative 11 is the coefficient of x cubed. There's no x squared, so it's a 0. Positive 10, negative 4. Straight down. Add 3 plus 0 is 3, because there's nothing there, it's a 0. Multiply. 1 times 3 equals 3. Add straight down. Negative 11 plus 3. 11 is bigger, so it's negative. 11 minus 3 is 8. Multiply. 1 times negative 8 equals negative 8. Add straight down. 0 plus negative 8 is negative 8. Multiply. 1 times negative 8 is negative 8. Add straight down. 10 minus 8 is 2. 1 times 2 is 2. Negative 4 plus 2 is negative 2. Since that's not a 0, 1 is not a solution. So let's try negative 1. The same values. 3, negative 11, 0, 10, negative 4. Bring down the first one. Negative 1 times 3 is negative 3. Add these. Negative, negative, answer is negative. 11 plus 3 is 14. Negative, negative is a positive. 1 times 14 is a positive 14. Add straight down. 14 plus 0 is 14. Multiply. Negative 1 times 14 is negative 14. Add straight down. 10 minus 14 is negative 4. Negative times negative is a positive. 1 times 4 is 4. Negative 4 plus 4 is 0. So negative 1 is a solution. Which is good, because remember I said here, we said we're going to have one negative answer. We found it. So we don't have to do any more negatives. We don't have to do any more negatives. We just have to find our positives. So, since x equals negative 1 is one solution, that means x plus 1 is a factor. Now we just have to look at this. Three negative 14, 14, negative 4. Remember, originally we had 1, 2, 3, 4. We had 5 numbers. We found a solution, so one of them disappears. We only have 4. We know 1 doesn't work. It won't work ever. So, but since 1 worked here, it may have a multiplicity. So we try it again. Add straight down. Negative 1 times 3 is negative 3. Negative is negative 14 plus 3 is 17. Negative and a negative is a positive 17. 14 plus 17 is 31. It's going in the wrong direction. So negative 1 times 31 is negative 31. So no more negative ones. They don't work. So the next number on our list is a 2. Let's try a 2. So a 3, negative 14, positive 14, negative 4. Bring the first one down. 2 times 3 is 6. Negative 14 plus 6, 14 is bigger, so it's negative. 14 minus 6 is 8. 2 times negative 8 is negative 16. Add these straight down. 16 is bigger, so it's negative. 16 minus 14 is negative 2. 2 times negative 2 is negative 4. We're close. But 2 doesn't work. Let's try negative 2. 3, negative 14, 14, negative 4. Negative 2 times 3 is negative 6. Add these straight down. They're both negative. 14 plus 6 is 20. Oh, this doesn't look good. Negative, negative is a positive. 20 times 2 is 40. So it's 54. Negative 108. So no, it's going way wrong direction. Negative 2 doesn't work. All right, so now next number we try is 4. So from our list here, all we have to do is try the positive since we already found our negative. 3, negative 14, 14, negative 4. Four times 3 is 12. Negative 14 plus 12 is a negative 2, since 14 is bigger. 4 times negative 2 is negative 8. 14 minus 8 is 6. 4 times 6 is 24. Is 20. Nope, not 4. Let's try negative 4. No, we don't have to try negative 4s. We don't have to try any more negatives. So the next one we try is 1/3. 3, negative 14, 14, negative 4. One-third times 3 is 1. 1/3 times 3, which is 3 over 1. The 3's cancel, it's just 1. Add these, I get negative 13. Negative 13 times 1/3 is negative 13 over 3. So we have 14 over 1 minus 13 over 3. We have to multiply this one by 3, top and bottom. So it's 42 over 3 minus 13 over 3. 42 minus 13, 29 over 3. One third times 29 over 3. Nothing cancels, so we straight across 29 over 9. So we have negative 4 over 1 plus 29 over 4. Let's get a common denominator, so let's multiply this one by 4, top and bottom. So it's negative 16 over 4 plus 29 over 4. Since these are not the same, 1/3 doesn't work. The next one we have is 2/3. Three, negative 14, 14, negative 4. Two over 3 times 3 over 1 is just 2. Negative 14 plus 2 is negative 12. 2 over 3 times negative 12 over 1. 3 goes into negative 12, 12 4 times. 2 times negative 4 is negative 8. So 14 minus 8 is 6. 2/3 times 6. No, times over 1. 3 goes into 6 twice. 2 times 2 is 4. We found a solution. So x equals 2 over 3, which means that x minus 2 over 3 is a factor, which actually means since this is the denominator, it goes in front of the x. So that's our factor. We found 2 factors. Now all we have to do is look at that equation. 3x squared minus 12x plus 6. Because at each term, whenever you find a 0, the exponent decreases. So now we have a quadratic. All these have a 3 in common. It's not going to factor, so we got to use quadratic formula. Negative b plus or minus b squared minus 4ac over 2a. We know it won't factor because what times what is 2? When you add them, you get 4. Doesn't work. A is 1. B is negative 4. And C is 2. Negative. B is negative 4. Negative 4 squared. A is 1, C is 2. So, let's work this out. negative times negative is a positive. Plus, so it's positive 4, plus or minus. Negative 4 squared is 16. Only one negative, so it's negative. 4 times 1 is 4, times 2 is 8. Running out of space. So we have 4 plus or minus 16 minus 8 is 8. Remember, 8 is the same thing as 2 times 2 times 2. So a 2 comes out. So it's 2 radical 2. On the top, 4 and 2, I can factor out a 2. Since 4 and 2 both have a common factor, I can take it out. I have 2 radical 2. The 2's cancel. So my answers are 2 plus or minus radical 2. Those are my last two answers. So our intercepts we calculated were x plus 1, 3x minus 2. It's x minus 2 plus radical 2, x plus 2 minus radical 2. Let's see how these work. We have x equals 2 plus radical 2 and x equals 2 minus radical 2. So if I move these equations over so it equals 0, I got x minus 2 minus radical 2 equals 0. Oh, it's minus. And then I have x minus 2 plus radical 2. So those are my 4 solutions. Remember, our degree was 4 and a was 3. So our graph would look like this. And our y-intercept was, where's the original function? Negative 4. Our original function was that. So our y-intercept was negative 4. We have a y-intercept, or x-intercept at negative 1, at positive 2 over 3, and then at x equals 2 minus radical 2 and x 2 plus radical 2. So 2 minus 1 point something, I say it's just a little under 1. 2 plus 2 radical 2. 2 plus radical 2, so it's approximately 3 something. The multiplicities of each of these are 1, so they cross. So this one has to cross and it has to go up. This one has to cross and it goes up. It has to go down. And then through these, they have to cross. So there's your graph. Okay. So that does it with polynomials. Now, since this is almost an hour, I'm going to stop and start another one for rational inequalities.